All right, so there's a couple objectives that I want you to know for the core exam. The first one is by look at the graph. So first objective is if there is a graph, and I want you to find the x values that make the function not continuous. So by look at this one, I'm seeing there is a place right there, which is at 2. So x would be at 2. And some of you are like, what about this one? Well, at that point, the graph is touched. There's no hole. It's a solid dot, so this is not it. Okay, so this does not count. So the type of discontinuity, if we look over here, there is a jump. So if there is a jump or a vertical asymptote, then it's non-removable. Non-removable, okay? So non-removable. So how we know when it's non-removable is when we have a vertical asymptote and jumps or break. What do I mean by vertical asymptote? So for example, if you have like a dotted line and you have a graph that going this direction, there's another piece going this direction. That is a vertical asymptote. Or another case, some question that we have today is how do we know when it's removable? It's something like this. If it's removable, if you have a graph going this direction, there's a hole. So something like that. So this would be this would be removable. Okay. So this is the first objective. Look at the graph. Can you be able to identify all the x values that make the function discontinuous, and then tell me the type of discontinuity is either non-removable or removable. The second objective is finding all the x, but instead of look at the graph, there is a function. So step number 1, we're going to set the denominator equal to 0. That's how we find the x, okay? So denominator x minus 3 equal to 0. Even though the numerator is the one you can factor out, but if you want to identify the x values, you focus on the denominator, because we want to know what x values make the function divide by 0. We don't want denominator to be equal to 0. So that's the point that we want to solve for. So x is 3. This values would make the function discontinuous, right? However, the question is, what type of discontinuity is this? Is this removable or non-removable? This is when you have to factor things out. So on the numerator, if you have trouble, factor it out, then see me for office hours. So this would be x minus 3 and x minus 4. And on the denominator, x minus 3. So you look over here, I have x minus 3 and x minus 3. If you can cancel out, then this one will be removable. So I'm not going to worry about the numerator. I'm going to look for the denominator and ask myself, is my denominator can be removed or not? I don't care about the numerator. I want to look only at the denominator. If I can remove that factor on the denominator, then it's removable. If it cannot cancel out, then it's non-removable. Okay, so that's another example that I want you to look at. Let's see this one more. Let's do one more. If I have this factor, now again, I'm going to focus on my denominator to find that x value. So I'm going to set this equal to 0. If you factor this out, it's going to be x plus 2, x plus 3, right? We solve for it by set each factor equal to 0. And then solve it. So minus 2, x is negative 2. This one is minus 3, x is negative 3. So the function is not continuous at negative 2 and negative 3. Now the question is this removable or non-removable? This is one of the questions one of you asked me today, is when you factor it out and when you determine the type of discontinuity, do we use the one that we solve for or do we use a factor? So if you want to determine the type of discontinuity, then I will use a factor because I'm not looking for a specific point. So I'm still using the factor, okay? So on the top is x plus 2 Remember, this is a factor that you have, x plus 2, and then x plus 3. So let's take a look over here. The x plus 2 should be able to cancel out. So this tells you this one is removable. And this one right here is still in the denominator, because when you cancel out, you're going to have something like this, right? So the x plus 3 is still in the denominator, so this one is non-removable, okay? And the proper way for you to show your work, I'm going to clear this part, and this is how, if you on the one with short response, I want you to show your work. This is a statement that you want to give me. F of x is not continuous at x equal -2, -3. So that's the first statement, and then you can say it is non-removable at x equal -3 and removable at x equal -2. So you're going to write out a statement to indicate that, to show me, give me that final statement, okay? So step number 1, set the denominator equal to 0, and then depend. If you can factor it out, then solve for x. If you cannot factor it out, then just solve for it, okay? To check for the type of discontinuity, then you're going to factor out both the denominator and numerator and see which one that you can cancel out on the denominator, and that's the one that's removable. All right, piecewise functions. Piecewise functions